Hello and welcome to the Code Me event channel. My name is Gabor Szabo. I usually teach Rust and Python at companies, and I also help introducing testing to companies and continuous integration and trying to help improving their um, development environment in general. In addition, I think it's sharing information, sharing knowledge is a very important thing in our community. And so we have this channel in the YouTube channel, Code Mavens, and these meetings that I'm organizing and inviting people from around the world to share their knowledge about Rust. So if you are interested, first of all, please like the video and join and follow the YouTube channel if you are watching this in YouTube. Also, join or below the video, you're going to find a link to where you can join or group. And I'm really interested in hearing suggestions for new other presentations about Rust. And now I would like to thank you for coming and for joining us and giving this presentation. So please, yeah. Please introduce your, yeah.
Okay,
Okay,
okay.
go ahead. Go ahead, sir. Just
Yeah, it's hard to remember and to pronounce my name.
yeah,
Yes.
I just thought, okay, how I'm going to pronounce your name? I'm not sure how to pronounce it. And
Yeah,
okay,
it's
sorry,
okay.
sorry about that. My name is also
Uh,
difficult to pronunciation for
yes.
non-Hungarian
Yeah.
speakers. Okay, so
Yeah,
go
so
ahead.
my
Sorry
name
for
is
that.
no problem. So my name is Borivoj Grujicic, but everybody calls me Bora, like in Ireland, Bora Bora. That's the easiest way to remember. Yeah, when I was younger, I was working on cruise ships, so all Americans, it's for them, it's very easy to remember Bora, Bora, Bora. Yeah, so Bora is simple to remember and to pronounce. Yeah, so I'm coming from Serbia. I'm 37 years old in a couple of days. Have two beautiful kids, 10 and 12. I'm a data engineer in expert group currently working for on different projects, working mostly with like American clients, healthcare companies, and I want to shout out to my colleagues that are working now without me because usually now it's working time for us. Second shift from 2 to 10 we usually work. So yeah, to cover this difference time difference. Anyways, yeah, I work as a data engineer, mostly working in Fabric environment, Microsoft, and yeah, you're gonna hear a little bit more about this in the talk, but this is just a quick introduction of myself.
Yeah, go ahead, share your slide and yeah.
Yes, okay, so let me just.
Just one more thing. Anyone in the group in who is around now at the live presentation, feel free to ask questions. Obviously, you'll be in the video, or ask questions in the chat if you prefer that way. And I'll when I see it, I'll read out the questions.
Okay, so you can see the slide. Okay, so very good. So Elusion DataFrame library for everybody. So why I'm usually saying like this, because my whole idea was to create something that would be easy to understand and easy to use by everybody in data world. So everybody who knows SQL, everybody who knows DataFrame, different DataFrame libraries. My goal was from the first day on when they come in to understand it. Okay. So as you can see below, I just want to mention one more time, shout out to my guys at the expert group. I'm going to see you later after this talk. So what we're going to talk about this today, about a little bit about me. I'm going to try to skip this fast. What is the motivation and what motivates me to create this library? Why another DataFrame library, right? We have such a great libraries already in Python world. And we're going to talk a little bit about data fusion because we cannot talk about Elusion without data fusion, because I'm heavily leaning on this SQL engine of data fusion. So I'm going to talk about Elusion a little bit. Then we're going to start covering a little bit of syntax and why I decided to do and how I designed the syntax and why I did what I did. Okay, so the whole idea is to promote the library, not myself. So I'm going to just quickly skip this part. So I finished music school. I think this is very important to have any sort of arts in your background, like painting, any kind of arts you go through. I think it develops creativity, so which is very important. So I want to motivate anybody who is in arts to join programming, I think you're gonna do very well. So I finished sports gymnasium. I'm finished master's in business economics. So I'm mostly heavily leaned most of my career in business. Only the last 4 or 5 years, I'm heavily coding and heavily programming. Before that, I was mostly in business realm. I started my career as a soldier in special forces. Then I went on a cruise ships. This was my younger days. And then I started working as in management, mostly in companies in, like, let's say top 5 to 10 people in some big companies. And then I started working as a logistics and production manager, where I first time implemented backend in Rust for the warehouse management system. I was switching from Java to Rust in that period. So Rust was a big revelation for me in that period of time. So, and then now I work as a lead data engineer, I mean, in expert group here in Serbia. And as I said, we working with a lot of foreign clients. So yeah, a lot of work for data people these days. Okay, so some programming languages that I learned, and I'm also doing some courses on Udemy, which you can also find Data Fusion, like introduction for the beginners, because I like Data Fusion a lot. And in December last year, I open sourced this library Elusion. Okay, so why would you use Elusion? Okay, so one of the things that I was obsessing about when I was starting this project is, okay, so what I don't like about other libraries, it's this enforcement that you forcing me to use your library and chaining your functions the way you create your process in the background. So this means that I need to remember for different libraries, I need to remember different syntax, right? So one of the things that is very important for me was, okay, how I can allow users to use their own logic to create their own queries and to get the same result. That was very, very important for me. And you're gonna see how I did this. So it has very simple DataFrame API construct. If you know already SQL and any DataFrame library, it's gonna be very simple for you to understand. Okay, you're not gonna maybe know how to write immediately, but when you see it, you're gonna know what actually this thing does, right? So if you wanna have power of Rust, of course, because it's 100% built with Rust, but without the need to know Rust. Thing that the let's say third thing that I was heavily thinking about, how can I create a library that any other programming language users can use? Of course, I'm mostly thinking about Python users, right? Because let's say Pandas, the most popular DataFrame library, it's such a, let's say, not simple, but it has easy constructs and easy, let's say, easy syntax to remember. Without knowing Python, you can actually work with Pandas without knowing how to build some complex thing in Python, right? So this was like very important for me when I create this to enable people that don't know Rust and to still be able to use this library. Okay, we also have native pipeline scheduler. So I created the scheduler with cron scheduling so you can automate your jobs. And we have native reporting and dashboarding. And today, this morning, I published 2.7.0 version, which I added AG grid to it. Before I had these interactive dashboards, now I added AG grid tables, which you can download to Excel and CSV files as well. So this is also very important for business users to be able to export to Excel, right? This is the whole circle, right? Export to Excel. Give me export to Excel button. That's very important for users. And one of the things, because I started as a backend development, for me, it was very important to have some sort of backend development capabilities. I consider working with REST APIs and gathering data from REST APIs part of the backend development. Okay, today data engineers work a lot of things, but my belief is data engineer do ETLs, but without REST API handling. Mostly backend developers should do this, I believe. So, but I also want to add REST API handling in the sense that you can take data from API, store it in JSON, then use it you can forward it to the DataFrame and work with it later on. Okay, so today we have over 10,000 downloads in just 1 month. So 1 month and 20 days, let's say, yeah. So I'm very happy with this, and I'm happy that people are using this. I get some nice feedbacks. I had also some nice suggestions from the community, so thank you for this. I had like much more experience. People working with Rust give me some very nice, very good explanations of things, how things should work, right? We learn every day, of course. Okay, so motivation, why I start this project and what still motivates me to work on this. Okay, so I love data fusion when I was working with data fusion. But the thing about data fusion, you have DataFrame API and you have this SQL API, right? So working with the SQL API, it's good, of course, native, it's good, but it doesn't give you any sort of an error while you're writing. You can write the whole SQL like this, and only when you execute, you get some errors and you can find where is the error, things like this. Here, when I separate the concerns for different functions, you can pretty quickly figure out like where is the error, find it. It's much easier to work with, right? Because it has this SQL execution kind of a type, but still has this DataFrame API function kind of a look. So it has like I think best from both APIs, let's say. But one of the things that is very important is that mixing different APIs from data fusion forced me to rewrite the whole library twice. So I will explain why in just a bit. Okay, so another thing, so this new norm in today's data world is let's build something with Rust and let's create Python bindings and let Python users use it, right? There's like a new norm today in data world. Also, Data Fusion is doing this, creating these wrappers for Python, just for the fact that should be easier to use, right? That's one of the goals of them, which I also have for this library. Same thing with Polars. They start with the Rust API, which was pretty hard to use for anybody who is not from Rust world. Then they create very nice API, right? So now everybody can understand this. Like not everybody, but who works with DataFrame APIs can easily understand what is going on here, right? They wrap all of their functions in Python, let's say, and you can now see and understand much easier. So this is like a new norm that is happening in data world, I would say. Okay, so as a data engineer working in Microsoft Fabric, I work a lot in notebooks, of course, and what usually can happen in one notebook, you can have PySpark cell, then you have SQL cell, then you have PySpark cell, SQL cell, and they go on and on. So I would like to have something. Why is this? Because usually SQL have their advantages, PySpark has its own advantages in flexibility and stuff like this. So usually when I come to some project, like in mid of the project, or some project is already developed, you come to the notebook which has PySpark SQL, right? So my goal was to create something that will have SQL query engine in the background to be executed like an SQL, but still to have some sort of flexibility like PySpark. So this was when the whole idea came from, to somehow mix these two to have one library that would replace both of these and to be able to work with it. Okay, so goals. I have a lot of goals when I was starting this. So as I already said, to create simple DataFrame API that can be understood and used by anybody, to make Rust fields approachable to anybody who is not from Rust, right? So already said, you should not be worried about if you don't know Rust. It's not a big problem, because you will see now how much of Rust you need to know to be able to use this. Very, very little. So as I said, to allow users to create their own query constructions. So if you want to start with join, start with join. If you want to start with select, start with select. You will always get the same result. So also create backend capabilities that was a part of REST API that I was talking about, and to create reporting capabilities. Okay, so as I said, we cannot talk about Elusion without data fusion, the king of all kings, right? This is what I believe. I think data fusion has great potential, but as I already showed, maybe in these previous slides, maybe it's not so easy usable by the DataFrame users. Like, or you need to know raw SQL, or this DataFrame API is a little bit, not so easy to use. So what I did for this library after I rewrote it a couple of times, and why did I rewrote it? Because DataFrame API, Expression API, SQL API, I tried to mix all together, like to use the best from all APIs. And then the query engine was so confused that I couldn't execute half of the functions. And in order to execute most of the functions, I would need to rewrite them from the scratch. And that would take me probably whole year. I don't know how much, but it would be a lot of time. So third time when I was start rewriting the whole library, okay, I said, I'm going to lean on the SQL reference. I'm going to lean on just on pure SQL, and I'm going to build on top of that. So all of the functions are going to execute any of these now functions that you can see on the screen. Okay, let's meet Elusion. So how Elusion came from? So I started to build maybe a year and a half, 2 years ago, some project that should be similar like Excel, but just like to use SQL instead of these Excel functions. This I didn't have time. At that time, I didn't have enough time on my hands to do this, so this project failed. And then when I started learning about data fusion, and I already have this project for Excel, somehow this Elusion came to my mind, and like this is the way I create this name, Elusion. Excel plus Elusion, right? Not very original, but this just came up to my mind. So yeah. Okay, so that's it. So why chameleon avatar? So what is Elusion? It's just like illusion, right? And because it's built on something like data fusion, what you're actually doing, you are triggering SQL query engine in the background. So it's just basically like an illusion, like a wrapper around this data fusion. So this, I think, comes together. Like you're using abstraction over something that is very powerful, very strong. So it's like illusion. So first thing that I thought is chameleon, because it can change colors and still do the same thing, right? Okay, so prerequisite to use this library. So you need to have at least 1.81 RAS because of the Delta Lake. I implemented Data Lake, which is not part of Data Fusion. So Delta Lake requires 1.81 RAS because of the writers. To be able to write Delta Lake, you need to have at least 1.81 version of Rust. Latest and the greatest solution is 2.7.0 from this morning, and Tokyo 1.42 for, and you need to enable features RT runtime multi-thread. Okay, so what I was talking about, not need to know Rust. All that you need to know from the Rust is literally main function, how to write this main function. Okay, so this use Elusion prelude will gonna give you everything that you need from this library, literally everything. And then when you create the main function, should be asynchronous, obviously, because this is made with asynchronous runtime Tokyo, which you put on top of this main function. As you can see, Tokyo main. I'm talking like this because I'm assuming there may be some Rust, some Python, or some other listeners. So you literally just need to know this 1, 2, 3, 4 lines of code from the Rust. Everything else you're gonna see it's pretty much similar to any other data frame. Okay, readers and writers. So to create a data frame, you don't need to establish schema. From version 0.2.5, I created a dynamic schema to be able to infer schema dynamically just from the file extension. So if your file extension is CSV per K JSON, or it's just a folder name, it's gonna know which file it's coming in, and it's gonna parse it like this, and it's gonna establish schema by peeking into the file. So there is like a function that is peeking into your first 100 lines of file, takes the data, creates a schema for you, already knows which data file is coming in, and using the proper loader for this. So what you need to supply for creating the new data frame is just the path to your file, as you can see, and the alias. Alias is very important. If you're importing multiple files and you're gonna need to join them later on, you need to provide alias, because you're gonna see you need to use alias dot volume name, very similar like when you're using SQL. So just the path and the alias is very important. And this is a asynchronous task, of course, so you need to add await. In Rust, it's like in any other programming language, when you have asynchronous runtime, you need to add await keyword, right? This question mark in Rust is just propagating the error. So if there is some mistake that you made or something that you didn't do right, this is gonna return you an error. It's gonna evaluate against the function that is running in the background. And I think that I provide very, very nice errors. I create all the custom errors. So you're gonna get some nice messages like, okay, check this, okay, check that. So I think I cover most of the things that you can make a mistake with. So I think they're very helpful, the error messages. Okay, so readers, so I also have database readers. So you're gonna see now, so for the database, and for the other things you're gonna see now, you need to have to provide the connection, which is created from the string, and you need to provide the SQL query. So besides the connection for the database, we also have the connection from the blob storage. Currently, I'm still trying to implement for S3 for AWS, still working on this, but currently you can take the data besides the files, you can take from databases and from Azure Blob Storage. Databases that I covered currently are MySQL, and I covered the PostgreSQL. So these two.
So sorry,
databases.
there's a question. I think I don't know. I missed it earlier. Just out of curiosity. I can't say this English in word in English. Which crate did you use for defining your errors? This error?
No. So Data Fusion and Delta Lake. These two crates have their own error, Data Fusion error and Delta error. So on top of these errors, I created a custom error. You can go, it's very easy. The project is very simple to navigate through on GitHub. So you can check the whole implementation literally like in one file for errors. So I just wrap those errors and create my own errors, which are gonna come from, is it a joining, is it a select, is it a string function? It's gonna target different parts of your code, and it's gonna evaluate against these parts. It's gonna tell you, oh, okay, check this, maybe it's this problem. Oh, check this, maybe joining is the problem. So things like this. Of course, this is not a bulletproof error system, but I'm still gonna work on it. But I'm trying to target each part. This is why this is very good when you separate functions for different parts of execution, that you can target errors much better to send to users what is actually the problem. Okay, so I said about MySQL Postgres, Azure. Okay, so for the Azure, you need to provide SAS token and blob URL, your container URL. This is current implementation. So with the SAS token and with blob URL, and filtering is optional. You see, some you can put none if you don't want. If you just want to grab everything from the container. If you want to grab certain part of the path, you just write there. Or if you want to just take a file, you write the file name. It's going to filter out everything from your container. You're going to find this file and download this for you. And of course, you need to provide alias for this table, because it's going to directly evaluate this for you, and add alias. So yeah, URL and SAS token. Okay, so JSON readers. This was one of the most difficult implementations I did here because JSON readers from Data Fusion and just any JSON reading is mostly leaning through key and value pairs. Very little implementations and very, I don't know, I couldn't find any crate that is can read arrays, objects, and flatten files. Usually you need to create your own structs and then like deserialize the data. So this was very, very challenging, not just how to implement, but to make somewhat performant, because flattening files, it can be very challenging for performance. So I implemented byte stream reading for this, and I think it's decently performant. But just for you to know, you can flatten if you have field and arrays, field and objects. Elusion gonna flatten this file for you and gonna fill all these places that usually you will need to create struct for or some more complex type to be able to deserialize. But I spent a lot of time on this, so you can easily flatten files. And of course, key value pairs are the most performant. It's just like blazing fast. Writers, okay. So we have Parquet writers, so we can write to a Parquet, we can write to CSV files, and we can write to Delta. This for the local files. So Parquet, you have overwrite and append mode. CSV, you have also overwrite and append mode. But for the CSV, you need to provide CSV write options. This is mandatory. Without that, we're not
Just a second. Just a second. I think Ray wanted to ask something. I don't know if you're still.
Yeah, if you don't mind.
No. Feel free just to jump in and start asking.
Yeah. Well, I sometimes it's better to hear more just to make sure that he wasn't going to cover it. But in terms of JSON, some databases do offer additional JSON interpretation. I know Postgres is really good at it. Even SQLite has some additional JSON functions where you can iterate through JSON structures that may be contained in one field, for example. But because you're basing everything on the Fusion, Data Fusion, or what is it? The Apache Data Fusion, it doesn't offer that. And so you're not offering anything other than what they offer, correct?
So for the databases, I'm not leaning on Data Fusion execution. I'm targeting through ODBC. You're gonna see later. So you need to create ODBC connection. So you can create. You can take two paths. You can just target directly database, write your SQL, and put all the pressure on the SQL engine like Postgres or MySQL. It's gonna wrangle data and it's gonna return the flat form for you, so in form of columns and rows. So you put all the pressure directly on the query engine of there. So this is not coming through Data Fusion. So what comes from Data Fusion is once you retrieve the data from the database, then when you push the data into the data frame, then Data Fusion runs the query that you wrote, right? So the whole point of the connectors is to take the data from any source and then to push it into the data frame, and then you work with the Data Fusion. So
okay. So that's important to understand. Are you going to get to this? Because I don't want to jump the gun if it's coming later.
yes,
so basically, you can work with other databases, and the way you do that is you're first bringing the data in from the database into your in-memory Data Fusion implementation.
Yes.
And then when you create a data frame, it's creating it within the Data Fusion namespace, for example. And when you create a data frame, normally in these SQL things, they haven't, that each table has a name. So do you name the tables, or does the name wind up being just like DF, for example? Is it the local name?
Yes. So yes, that's a good question. Like this part of the implementation. So I create a very crazy aliases that I assume nobody will hit when you create a query, but you need to apply your own alias. So this my crazy alias will be replaced with your alias. So that's how I overcome this. But yeah, you don't need to worry. I'm pretty sure you're not gonna hit the alias that I wrote for when you trigger the database. But later on, when you provide your own alias, it's gonna be replaced. You're not gonna feel this. You're gonna know this. You just supply your own alias and then you work with it later on.
Okay, I'll let you continue. Thanks.
No problem. So for the CSV writing, so you need to provide delimiter, escape quote, double quote, and null value, how you want to replace the null values. And then it's going to work. So has headers, it's true. So you need to work with headers. I don't think anybody in data will work with CSV without headers these days, maybe, but I disabled this. So if you want to work with CSVs, you need to have headers, right? And I just want to say for the partition, I don't know if you can see this part that says delta, but it's cut with this thing on my screen. I don't know if you can see it, because I can see the screens of who is on camera. But anyway, so for delta partitioning, so you also have a very important thing to know. When you want to partition the table, you see it's optional. It's the third argument for partitioning. So I wrote here sum, a vector, and the name of the column, and dot into. It's very important for you to know you're not going to be able to retrieve this column anymore once you partition the data on. So my recommendation is create new column, which you want to partition the delta table on. So if you want to partition on date or on integer, mostly it's dates or some integer, create new column. However you want to call it, and then partition your data. That's very important, because once you want to read back the data, this column is not going to appear because it's sucked in partitioning. For appending, when you want to append on data table, make sure you have the same column name and the same column that you already partitioned on, to have this same column on this new data that is coming in, because otherwise it's gonna fail. You need to have the same column name and the same data type, is date or is integer, right? To be able to partition and to be able to append on the delta table. So that's very important for you to know. This is currently how it's implemented. Okay, so just want to say, if anybody want to create data frame, just for you to know, overwriting is easy, appending is very hard to implement. Very hard. If anybody want to try this to do, it's very hard because you cannot lean on any implementation is coming, because at this point you're gonna have so many different intricacies to work on, and you're gonna need to implement. You need to work against your record batches, and you're gonna need to work a lot on performance. This is much harder to append than to overwrite. For overwriting, I usually use the native overwriters of the Data Fusion for the CSV and Parquet, but appending it's not working. So you need to. So just if anybody would try to do something like this, it's much harder to append than to overwrite. Okay, so to Azure Blob Storage, writing is currently only supported in Parquet. Why is this? Because at my current one of my current projects, I had this requirement to grab the data from API and to write into Azure to Parquet, like more file types work come. I will implement for JSON writing as well and CSV. For now, only the Parquet file you can write. So this is just a small example. So let's say you have some data, custom data frame, df.select. Here is just like an example. Of course, it can be much more complex. Then you state your URL to your container folder, SAS token, and you use this data frame data. You see above where it's called query.elusion. It's very important. Elusion function is like an execute function in other data frames. So Elusion is actually evaluating your query, and it's creating a new alias for the later on usage. If you want to use multiple, like in same execution, you want to use the same data source, and you want to create multiple queries until you come to your final query. So it's very important to use Elusion evaluation. Before that, you don't need to use it. You can just chain, and then make sure to use Elusion. It's like an execution on top of all of your queries. And then you can see this, use write parquet to Azure with SAS. I try to create all the function as most logical as I think, like to remember. I'm writing parquet to Azure with SAS. So that's how I name my function. Somehow, for me, it's easier to remember. I don't know if this is very practical, but yeah, maybe somebody gonna disagree with me. But for me, this is easy to remember. Write parquet to Azure with SAS, and this is how I call this. So you have two modes: overwrite and append. And as you can see, you provide your URL to the storage and the SAS token. So for writing, it's very important to make sure for SAS token that you have writing permissions. So check this. Some of my colleagues are persistently trying to write with SP tokens without writing and creating permissions. So make sure to have this inside. So writing is set to default, compression is snappy, 2.0 parquet, and the buffer size I put 1 GB. I can extend this, but I think 1 GB is it's a big parquet file. So like I set this limit. This mostly also for my purposes. If something goes wrong with some API, not to make a big bill for my company. So data wrangling. So we're gonna now cover a little bit of syntax and a bit of design. So we're gonna go through different functions that I created and why I decide to use some things in some functions and take it out from other ones. So when we talk about select has case insensitive S, so you can use capital S or S small. You can see here. You can of course select star. You can select everything. Or you can select count everything and etc. So from this first glance, you already, I think you understand what is going on here. I think you already realize that I created functions which are gonna give you greater flexibility, but you're gonna still be able to use this sort of a SQL syntax because, of course, we are targeting Data Fusion SQL engine in the background. So this is kind of a design that I created. Maybe you're not gonna like it, maybe you're gonna like it, but we're gonna see now. So for numerical operators, so currently operators that are supported is plus, minus, multiplication, division, and the mode. So later on, you're gonna see in which functions you should use which. Currently, you can see a small example here of how you can use the filter. Filter is basically like where in SQL. So you're filtering pre-aggregated data with filter. Having, which you're gonna see later on, is filtering data after aggregation, like very similar like you have in the SQL. So for order by, here it's a single argument because you also have order by many, which you can supply multiple columns to order by. Currently, I have for ascending and descending, I have true and false. Still thinking how to implement this, maybe just to be able to add ASC or DESC instead of true false, but currently it's true false. True is ascending, false is descending. And limit, we all know what is limit. It's just you're limiting the amount of rows you wanna see, and then you evaluate with Elusion. As already said, you added a new alias because this, if you want to use it further, you can evaluate with Elusion function, and then later on you can use it in other query. And display function, we already know what is display function. It's just gonna display the data frame on the console for you.
So on this one, before you go on, the first part, when you're creating this variable called num_op_sales,
yes,
the functionality there just pretty much constructs the query, right? And then in the let down below, that actually essentially executes the query. Is that the way to think of it?
It's exactly the way you should think about it. So you chain. Then with Elusion, you're what is the point? In Elusion, we have another function in the background that is called construct SQL, which you're never gonna see in for usage, but it's in the background. So the way this functions and why you can actually write in any sequence the function says like select, filter, you can like literally mix up and down any of these functions. Is going to work the same, because when you evaluate Elusion, it's constructing in the background the SQL query in the order which query needs to be constructed.
I see. Okay.
So now you need Elusion to evaluate your query that you wrote against SQL construct in the background. And that's how I implemented this. Okay, use whatever you want to use, and however you want to use it is going to give you the same result in the background. So this is like why this
so
is.
except for is there, in other words, I'm trying to figure out what is the benefit of using Elusion. Certainly you get that benefit because you don't have to get these in the right order, and you're checking that in creating the query properly. But pretty much you have to know about queries and how they all work, very much like a regular SQL query, right? I mean,
yes,
it's very much
yes,
the same syntax.
very much similar, but you're gonna see some advantages. As I said, it's I'm trying to make I already made it, but mix of PySpark and SQL. So to have flexibility to write the way you want to write, you don't need to use like select everything from where this, group by this, order this, right? You don't need to write it like SQL, but it's basically like a SQL, right? But it just you have this flexibility to write it any way you want to write it. So that's like the whole idea.
And then the result of this, so when you do an execute, then would you get out of that an object which is, you get this object, nonops res, and then you say dot display. Now, is that nonops res, is that like a proxy object that is?
It's new DataFrame object. It's new DataFrame object. Yeah, so against this nomops res, now you can chain more. So for example, you aggregated something, or you join 10 tables or whatever, and you evaluate nomops result, nomops res, then this variable is going to hold result of previous query. Then you can work later on if you want to union something or append or whatever you can use against this. So because it's storing a data frame which is evaluated with Elusion, right? So
is that always a new frame in your mind, or do you sometimes return the same one? Like if it's a join, well, maybe we're going to get to join, so I'll wait.
Yes.
Okay, thanks. I'll stop there.
Okay. So filtering, as I said, you can filter many. Very important thing, which I'm still dribbling in my mind. I want to implement inline parameters. I'm going to talk about this at the end. So current implementations and development. But hopefully, if I figure it out the way I want to figure it out, so soon we should have also be able to use inline parameters, meaning you can create some scalar value or just any value you want to store in a variable, and then you should be able to evaluate against your data frame column. So this what is coming, but currently you have filter, which you saw before, and you have filter many. Just make sure to make it in square brackets, because it's like a list, right? In Rust, I'm talking like this because of the, I assume, Python users. So you put in square brackets, and each filter you separate with a regular like close bracket. So this is how you create multiple filtering. Again, as I said, filtering is used for pre-aggregated values. So having is used after aggregations, but you're gonna see now. Order by we covered, and everything of this we covered already. So scalar functions. So scalar functions are used exclusively in select function. They will not work in other functions like aggregation and like string functions that I created. You're gonna see now. So you can use scalar functions directly in select. Of course, you can use these nested scalar functions as well. Filtering we covered, but we covered already. So aggregating functions. So aggregating functions, of course, can use nested functioning. So round, average, absolute, but also can use operand-based aggregations, as we also see previously in the select function. But here, if you use aggregate function, you can also like Elusion is able to evaluate your operator-based aggregations as well. So just something to have in mind. And we come to the new function, group by. Group by have two variants. You're gonna see now have group by and group by many. I try to use the similar logic for everything. Is it single or it's many? Group by or group by many, right? Filter many, order by many. So everything is like this. And usually is the same. So currently group by, you obviously need to put all the non-aggregated columns in order for this to work. If you miss some non-aggregated column, it's gonna fail. You're gonna get error message. For group by all, it's automatically evaluating all of your non-aggregated columns. So I usually just use group by all if I need something. But of course, if it's small enough example, you can use group by as well. Okay, so now we come to the more complex query instruction. So select aggregation, filtering, group by all, as you can see below. So group by all is gonna evaluate all of your non-aggregated functions, and then it's gonna give you the right result. And ordered by many, as you can see here, is similarly used like any other multiple argument function. So you put square brackets, and in individual brackets you put the conditions, right? So in this case, total billable false and max absolute billable value. And the rest is the same. You use Elusion evaluation and you work on it as usual. Okay, so currently supported functions are these. So for aggregations and for scalar functions. So this is what is currently supported. I think is more than enough, but if somebody has some suggestions, please let me know, because you would think, okay, I can use probably everything from SQL. No, you cannot. This is still restricted because I'm parsing this very heavily in the background. Each of these words, each of these bracket, everything from this, it's heavily parsed in the background. So like if I when I say, okay, this is supported, literally this is supported. So if anybody needs more, please just you can easily find me, and if you need some more functions, but I think this covers most of what is needed. Okay, so joins. So we have different type of joins. So we can join two data frames. For joining two data frames, we're gonna usually use join. So you're gonna, very similarly like you in any other data frame libraries, you provide this, for example, DF sales, this some evaluated data frame from before, and then now you have another data frame that you had somewhere above in your code. Now you want to join these two. So you have DF sales and you have DF customers, and then you provide the joining column. And of course, you provide the type of joining. Is it inner, left, or whatever? And the rest is the same. Aggregation, group by, having. Okay, so having, this is single having, and you provide total quantity greater than 10. As you can see, it's evaluating against aggregated function. This is very important. So having, filtering aggregations, filtering before aggregations, okay? This I'm saying like this because if you don't know SQL, this is how usually in SQL as well. So, okay, this for single joins. Okay, so we have, if you need to join more than one data frame, you can use join many. So in join many, again, same as any other many function that I show already, square brackets, individual brackets for different data frames. So here we are joining 3 different data frames, first one, then the second and the third, and the rest is pretty much the same. Besides this, what is also supported is joining on multiple columns. Okay, so joining multiple columns for 2 data frames, we again use joining function, but you also can provide in the square brackets multiple columns, 2, 3, 4, however much you want. Same thing goes for the join many when you want to join multiple data frames. Again, same thing, square brackets, then you put individual brackets, and inside you supply multiple joining columns. Very important thing to know, is what restriction we have right now here. The restriction right now here is that you cannot join uneven number of columns. Which means what? Which means if you wanna join first and second data frame on 2 columns, and you wanna join first and the third data frame on 1 column, it's not going to work. So you need to have equal number of columns. Currently, I was unable to implement this. It was failing in testing. So I currently I still didn't finish this implementation. But currently, just for you to know, this is the limitation. So if you want to evaluate on multiple columns, you need to have a same number of columns that you are evaluating against. Okay, so now we are starting another function. For me, it was the most logical thing to do. When we work on string columns, okay, so we work on string columns. My whole idea to create this new function called string functions, which I don't think you have in any other data frame, so maybe this is going to be a little bit weird for you. But for me, it was very logical if you want to work on some string function or like any function that of course have string type UTF-8, or if you come from JSON or any other text, varchar, whatever, from whatever data source is coming and whatever string kind of type it has, you should use string function. Because string function is differently parsing in the background, is differently parsing in the rest of the functions. So if you're gonna place some string function in select, it's gonna fail, it's not gonna work. So make sure if you are applying some function that is usually working on string functions, make sure to put it in the string function, as you can see just here below select. So yeah, so we're gonna talk about more string functions just now. So this is more example, as you can see here, join many, select, string function, aggregation, group by all, having many, order by many. As I said already probably 5 times, you can literally write here, select, string functions, join, aggregation. You can write string function, select, aggregation, join. Literally, you can write here, however is most logical for you, it's gonna work the same. And now, as you can see, string functions have all these trim, concat, left, right, all these most usable, like most frequently used string functions.
Okay, quick question. When you do joins, can you join without doing the aggregations and
Yes,
selections and create views?
No, you cannot create views because everything is stored as a data frame in memory. So I don't have lazy evaluation like Polars has. For example, Polars has lazy evaluation. So you write, and only when you execute, then actually do something. Here, there is no such thing as a view. You cannot store things as a view. You can only store things as a data frame in memory. So
Is that part of Apache Data Fusion functionality that they don't have views?
yeah, they have views. You can create views, but I didn't implement it.
Okay.
So the way I implement this is everything come and go through the data frame, everything come and go through your local memory. So this is how I implement this. So you cannot create if you're saying view, you want to create a view, where you want to create a view, in memory, or you want to create a view in a database?
Because it's in memory. I mean, this thing operates in memory. You're not operating off on a disk somewhere, and that's the limitation of this, right? Because you can't have too big of a data frame; it will run out of memory. And then
depending on of your memory of computer, if you have 32 gigabytes of memory, you can.
So if you have you'd have to have RAM though. It can't be on disk, right?
Yeah.
So even SQLite allows you to have some pretty large tables, and then what they do in those other SQL, maybe I haven't used Data Fusion before, but they let you make views, and then in order to make then you can join 2 tables, you can join another table, you can join another table, and nothing happens until you select on it.
Yes, yes.
And then once you
lazy
select
evaluation,
on it,
yes, I know.
then it goes back and it figures out
Yes.
how it's going to, you know, because it has to behind the scenes, you know, take the first one, get the key, you know, find the other one, find the key in that one, get the data that you're looking for, pair it up, you know,
Yes,
all
yes,
the way through.
Yes.
Okay. All right. Thank
Yes.
you. That's my question so far.
Yes, yes, yes. Yeah. So it is what it is currently. It's built for in-memory data format without lazy evaluation. So when you run it, how you construct your query, at the moment you evaluate, it's going to start crunching your data. There is some optimization for compressing bytes and everything, but you cannot go over your limits of your local machine. That's impossible because this is for in-memory data formats, like similarly like pandas, like, you know, Polars has more advanced lazy evaluation. So similarly like PySpark is lazy evaluated as well. You can write. You can store, use, whatever, and then you execute, and then it's figuring out, and then you wait for 5 minutes to execute. Here it's a little bit different. It's quite performant, but you have this limitation of your own memory. It is what it is. Okay, so currently implemented joins inner left, right, full left, same right, same left, right, and the left mark. Thing covers most of our normal humans working with data. String functions. Okay, so as I already said, let's just repeat a little bit more and show a little bit more examples. So in string functions, you can, of course, create new columns non-existing, like this, like new as new old customer. You can add string values to the columns. You can, of course, use all these string functions as usual. Here are more examples: left trim, right trim, upper, lower, length, left, right. Any, as I already said, not to repeat myself, any string functions you need, just feel free to put it in the string functions. Yeah, so that's it. More examples here: replace, translate, repeat, reverse, left pad, right pad, and all this other stuff. Still, I'm working more on string types with dates. There is casting, there is to char and stuff like this, but I think I still didn't cover all the time and date functions that Data Fusion has natively. Still need to go through all of these, but most of the like general things I covered. So these are the currently available string functions that you can use in the string function in your query. Okay, so windowing. Windowing, I was thinking how to implement this because you already saw there is mostly this logic. We like filter many, order by many, things like this. But for windowing, it's overly complex to have window many because now you're not going to be able to figure out, for me at least, for writing errors was a little bit difficult if I have window many and I have a list of windows to actually to designate which one is failing. So for me, it was a little bit easier to implement this like this. And I think it's also enough. It's more than enough complex windowing to have it as a single function. So I implemented like this, so you can do aggregated window functions, ranking, analytical window functions, and you also can do rolling. So anything that you need, I think it's covered here, and it's going to be properly parsed. This was the hardest thing to implement for parsing because it can get pretty quick, pretty complex. But yeah, I think I covered the most cases for windowing. And you can use, of course, in windowing for aggregations, as I showed before, all the aggregation functions you can use here. Here we can see sum and average, but you can use all the other that I showed before for aggregations as well. Yeah, that's it for that. Okay, append many. So I also added, this was not necessary. This is literally like union and like union all and union all many, literally the like same functionalities. But I know some people like append and can remember is there append, so you can use this one as well. It's gonna keep all the rows. It's not gonna remove duplicates in any case. So what I think it's I'm a little bit biased here. In PySpark and other data frames, you need to, if you want to append, if you want to union, if you want to do any of this, you need to provide data frame, dot function data frame, dot function inside data frame. But here I implemented, if you wanna append multiple data frames, you just literally say append many, and you just add each data frame you wanna append. So I think it is a little bit easier usage than in other data frame libraries out there. So yeah, you can see example here, 5 JSON files, you create data frames, you do some whatever. This is just simple like queries, You evaluate all of these. As I said, if you want to use it further, you evaluate through Elusion. You need to do this, and then you can use it in append many, and all these other functions that are coming right now. You're gonna see union all except and intersect. So union combines rows for both and removes duplicates. Union all, as I said, similar like append many, is going to keep all the rows, not removing duplicates, except and intersect, difference between two sets, and intersection of two sets as well. So this is a small example of union. So you have two data frame, df1, df2, and then you evaluate through Elusion, and then you union these two tables. And same thing is for union all except and intersect. You provide these two.
So do the columns have to be exactly the same?
Yes, need to be the same, need to have same number of columns, need to have same data types, need to have same column names.
Thank you.
Thank you for this question, because I would forget to say this. So union many, union all many, same logic. So you create 5 different data frames. Union many, you provide just the first data frame, because on the first data frame, this is very peak on the data, and this is how I establish after the evaluation. I establish I need to establish again in this case the schema, and then against this first file that you provide, first data frame that you provide, then I'm comparing all the rest, right? So yeah, so union many and union all many, it's yeah, so you can see union many, same thing like union, just with many. It removes duplicates, and union all many is same like union all, just you can provide multiple data frames. It's going to keep the duplicates. Okay, pivoting. Okay, pivoting was challenging, very challenging, and pivot and unpivot, because pivot and unpivot are not supported by Data Fusion natively. So I need to create pretty interesting workaround this thing. So very important thing, this is a synchronous function. It cannot be chained with other functions. So just remember this. You cannot write select target string and then chain pivot. It's not going to work. Pivot and unpivot are separate functions from other functions. So you need to evaluate your data frame to work this. So you're gonna, let's say you wanna pivot directly on the row CSV. You create custom data frame and you pivot on the data frame. Or another version, you work your chaining, you write your query, and then you evaluate with Elusion, and then you can use pivoting. So you need to provide Elusion, then separately on this data frame, you need to pivot or unpivot. So this is just an example here on the screen. CSV files, little bit of data crunching. You use Elusion. This display is not necessary if you want to see what or not. You can remove this. But then on this scalar results, scalar res, you can pivot now. Okay, so it's very important to know this part. You cannot change. You cannot add pivot above. Let's say after filter. You cannot do this. So you need to be used separate. Okay, I don't want to go in the story about futures, but when you work with asynchronous runtimes and asynchronous functions, just as I said at the beginning, use await and the question mark. Just remember this. You don't need to think about this too much. Just await, dot await, question mark, dot await, question mark. That's all you need to remember from the Rust. You don't need to worry about this. Okay, unpivot, same story, identical story. You can work directly on the data frame, or after the Elusion evaluation, you can just call your unpivot. Okay, statistical functions. Statistical functions I provided, maybe I'm gonna do more, but for me, when I work with data, it's very important to quick evaluate the data frame to see how many nulls I have, how many rows, like just checking the data a little bit. So I create 3 different statistical functions. So here you can see on the data frame, so you get some metrics for the columns. You have how many records have, how many non-null values, mean, standard deviation, and min and max range. Just a little bit that you have some, idea about your columns, what is going on. So here you're gonna get a report for each individual column. I didn't put all the columns, it would be too big picture, but below this you're gonna get two more results, right, for each of these columns in your data frame. Of course, if you wanna for example create null analysis, which I usually do, it's kind of a thing to do to see how many nulls you have in the data frame, one of the things to check your data. So you can provide none. In Rust you have this option type. It's like, think about this like let's say, is it or is it not? I can use it or I don't need to use it. It's just optional, right? In the background it's a little bit more complex. It's actually helping you not to get the null if you checking some value, and if it's gonna come null, just to cover this, not to get these problems with errors. But just think of this like a option, like the thing, I can use it, I don't need to use it. In this case, you don't need to use it. And what you don't need to use is to specify the column name. If you just like say data frame, any data frame that you created, and display null analysis none, is gonna evaluate all of your columns. If you provide the column name in the how you call this, in the braces, how you say, then you're gonna evaluate on the column. But if you want to just place none, it's gonna evaluate the whole data frame. Usually you use this, but anyways. Okay, so display correlation matrix. For some people, I don't usually use this, but if you have any need to see correlation between the columns in your data frame, you can supply the columns, and then you're gonna get correlation between the columns. Usually, I think this is used from data scientists. They usually do this. I don't usually do this, but I implemented this just in case if anybody needs it. Okay, so we come now to the ODBC, Open Database Connectivity, and talking about MySQL and Postgres, which I implemented here. So for MySQL, if anybody work with ODBC connections before, you need to know that you need to have a driver. Without a driver, it didn't work. It's not going to work. So you need to have locally your driver installed for your MySQL. So currently, for example, I use this 9.1 Unicode driver. And then it's very important for you to remember, you need to supply these keywords as they are right here on this screen, because SQL is looking for these keywords. For Postgres, it's different keywords you're going to see now. So basically, this is in multiple rows, but this is just like one string. I just, as you can see, I slash it just to have, I can see it nicer, but you can just place this in one line as well, of course. And then, as I said before, try to push as much as possible pressure on the SQL server. So don't put too much pressure on data frame execution, because you want to get from the, I don't know, I test this on 1.6 million rows of data with 32 columns with 2 tables. So you have very nice performance, but try to put pressure on the SQL, in the SQL engine. So don't put too much pressure, because if you have multiple tables you need to join with multiple million rows, I don't know, 5 million rows each, I don't know, it's going to be too much for your memory to do this. Like, put crunching as much as you can on the SQL engine. So or limit amount of rows you want to take. If you can also like limit 20,000, 100,000 rows. It's going to be extremely fast without you importing all the data. Once you are happy with what you get, then you can remove limit clause and just run your query as you want. Just my recommendation, don't try to break your computer, right? So once you create the connection string and the query, you just use custom data frame from DB, where you're gonna create the execution, then you need to use Elusion and give it a new alias. As I said, in the background, I create the crazy alias when I running from DB, but you don't need to worry about this. Add your alias in Elusion evaluation. Then later on, you can work with you can change your functions, work with DataFrame as usual, as we already saw before. So similar to ODBC, remember these names. So driver, server, port, database, UID, PWD. So this is what Postgres is expecting. It's a little bit different than MySQL. And then, yeah, so driver is PostgreSQL Unicode that I'm using. You're gonna maybe need some, I don't know which version of Postgres you have, but just check which driver you need. Install the driver on your computer, and then you can work with your database. And same, just create Elusion evaluation, give it alias, and then you can work it later on with a data frame if you need. Why is this? Why would you use this? Like if you can run SQL directly on SQL. Let's say you want to work with you have an analyst in your team. You want to give them the data from the database, and then they work in Fabric. So they have native Gen 2 data lake connection with Azure. Right. So you take the data from the database, you push data on the Azure, and then they take it in Fabric and they work later on whatever. So just this is like, let's say, use case for or if you do locally and publish, let's say, Power BI reports or Tableau or whatever reports, you crunch the data with a data frame, you give CSV files to your analysts that they create locally, they publish to the cloud, the reports. I don't know, like there are different use cases in expert group. We have different clients, some smaller Serbian clients that we have, like some furniture company, they work like this. We have VPN to their computer, to their station there in the company, and we just supply from the database the files, and locally analysts are creating reports and just publishing. So smaller companies need smaller solutions. Bigger companies need bigger solutions. But yeah, you can find use case probably for yourself. So Azure Blob Storage, we already talked about this, so we don't need to talk too much. So reading from the Azure Blob Storage currently supports CSV JSON. Still, I need to implement the reading Parquet. So it's opposite way. I can read JSON and CSV, and then I can store Parquet, but I cannot read Parquet. Okay, so currently, but I'm gonna implement reading Parquet and storing JSON and CSV. I'm gonna do vice versa as well. So as I already showed you, very important thing, if you didn't work with Azure Blob Storage before, just check URL to your container. If it has the word blob, that's gonna run on the SDK, Azure SDK, which is not performant. If you have word DFS, it's gonna also work through SDK, but it's gonna be much faster because it's using Delta Lake Storage 2nd generation. So it's much faster. So ask your principal or whoever who is your manager, just, okay, please give me DFS code, right? So DFS URL, so it's much faster execution and reading and everything. Okay, so you provide your URL, your SAS token, and then you use from Azure with SAS token, very bluntly function name, but from Azure with SAS token you use to create custom data frame. Again, you can use filtering, you give it alias. Here I just give alias data, and then later on you write your query and you work with your data. If you need to put back your, usually, so for example, we have one company from Dubai, Emirates, so we take the data from in JSON format and we store it back in Parquet, for example. This is use case. So you can take the JSON files, which are like, you have like, I don't know, over 500 JSON files. We take it, we do some aggregations, calculations, we pack it in a Parquet, and we push it back to the Azure. So this is one use case, that a real life use case as well. Okay, REST API. Okay, so REST API, I tried to put as much as possible things I could, the most like flexible options I could think of. So you can write from API, just simply, this is the most simple use case. You just give the URL and you just give it the path. So all the from APIs, all REST API implementation is taking directly from the API data and storing in JSON in your local files, right? So you just provide the URL and you provide the path and the name. I just made this before. It was in the first implementation was separately path and the file name. Now I think it's easier to use it like this, where you just remove this argument. So you use two arguments. So yeah, this is from API. And then from API with headers, so you can just create a hash map. So hash map, in other programming languages, you have different data structures, right? Hash map is one of the structures you can use. Without going too much into the hash map, you're just basically storing different values before you're gonna use it here. So if you're gonna create multiple headers, so you're gonna create hash map, which you're gonna use later on from API with headers function. So as you can see here in example 1, you create mutable headers variable. Because why is mutable? Because you are adding more stuff to it, so it needs to be mutable. You are changing the structure, right? Rust is very strict of this of types, because Rust natively when you create a variable, it's immutable by default. So if you want to create mutable variable, you need to put this word mut, so mut. So now you can change this variable and store multiple things in a sequence in the variable. So this is a simple example with a single header, which so now doesn't make much sense, right? But it's gonna make more sense in the second example, where you have two headers. Now you can store multiple headers, and then you can use it from API with headers. And it goes on. I don't want to bore you with this, but you can check GitHub repo. You have much more example. So parameters also, hash map, you create hash map, you insert parameters and use parameters. Then you can mix with parameters and with headers. So now you have parameters, you have headers, and you supply this to the from API with params and headers. So I try to create as much as possible. This is from just if you need dates, you can use this one with dates. You evaluate some data from date range. If you need like for 1 year data or something, you can use this one. Also, you can use this with parameters as well, of course. But I just create if you need something more specific. Pagination, so you can grab data with different number of pages and how many rows per page you want to grab, depending if data is huge or something. So you can paginate the data and then evaluate to the data frame. With sort, you can also sort like before. Even you using the DataFrame API from the Elusion, you can sort the data before you receive the data. With headers and sort, so headers and sort and so on. Okay. Now, this is the last, the most relaxing feature I implemented. This is my favorite feature because this is the easiest thing to implement, in a sense that it's it's the most creative thing. Here it's not so much technical. It's a lot of JavaScript. So JavaScript is very flexible. So here we have added ability for reporting and dashboarding. So you can create plots and you can create tables from today, last version, latest and the greatest. So these are currently available plots. Here is an example. So plot line, plot block, plot time series. I don't want to mention all of this. You can check on the GitHub repo. And then X and Y axis, you give it a true for line. If you want to have these dots and see, you're gonna check I don't want to talk too much. It's super simple. So it's natively baked into the data frame. So after you create data frame, if you want to create a report, you can create your plots. You're gonna see now, and you can create your tables. Okay, this is more example of plots: histogram, box plot, plot scatter, and then you can create tables. So you create some query. So now you want to take certain columns from the query and you want to order it or whatever, and you need to pass it through Elusion to create the alias again, just for evaluation. You need to do this, and then it's ready to be used in dashboard. So you create a list of plots that you create. For example, if you create line, time series, you pass this to the list. Same thing for the tables. You pass all the tables that you created into the tables. And then for the report creation, you create report layout and table options, how you want to have your layout for the report. 2 columns, 3 columns, 1 column, grid gaps and everything. You can check on documentation there as well. And the table options. You want to paginated tables, you want to, what kind of tables you want, etc. You can, all the options you can check there. And then you can edit. LG Team Alpine is I think I like this one the most. Keep this one because it have green lights like our chameleon. So I using this one, AG Team Alpine. So it's have very nice and modern look. You're gonna see now. And then as a final step, you use create report. So you're adding the plots, you're adding the tables, report title, and where you're gonna create your HTML file. So now the whole point is you are creating report into the HTML file, which you can share with anybody with your company. Of course, bigger solutions have much more advanced this, like Tableau, Power BI, whatever, but I wanted to create this full circle of taking the data, crunching the data, creating the report. This was very important for me because this was my dream for a long time now. So I want to create some full implementation of this whole circle. As you can see here, was sum for Python users and other programming language users. It's again optional. You can keep it none. If you don't have plots, you have just tables, keep none for plots, and vice versa. So everything where you see sum, this is optional. You don't need to use it. Same goes for layout config and table options. I create default structures for the report. So if you want to use default structures, you just keep this as none, N-O-N-E, and it's going to create for you. And now we're going to show you the demo, how the report looks like. So this is the tables. This is AG grid table, so you can sort it, you can reorder the columns, you can just you can make it easier to look and whatever you want to do. You can of course filter, you can choose the dates and stuff like this. For the plots, of course, you have this different information you can see from. You can zoom in, zoom out, stuff like this. You can slide on the timeline. This is for the time series if you need. And then most important thing for the users of the business is export to Excel button. Of course, now we have export to Excel and you can export the tables. Of course, you cannot export the plots. You can export everything what you placed in the tables down below. Okay, so that's about it.
Okay, so I got some questions. I love your dashboard thing. That is really tremendous. I think that's a real selling point. Now, when you're reading CSV, it normally comes in as strings, right? So how do you get the data types? Is there some functionality where it tries to guess what they are?
Yes, Arrow. I'm using heavily Apache Arrow, my best friend in the whole world. Apache Arrow. So I'm peeking into I'm peeking, as I said, in first 100 rows of the data, or 100 lines, depending what it is, or if it's JSON, couple of objects, and then I'm comparing against all the possible existing Arrow types. And then Apache Arrow does this actually for us. So it recognizes the data type and it stores it. If it's not able to recognize, it automatically goes to UTF-8, meaning from UTF-8 to string. If for example, there is some like very complex date formats, which currently recently I was working with some POS data from the cash register, and the dates on that is like 01. Name in the string, then you have the year, then you have these time zones, then you have all this. So it's kind of hard to evaluate all the data types, right? But 95% of data types are covered.
Mostly dates. But what can you override? Is there an override to set the data types? Because since Rust is very picky about this.
No, it's not.
You're stuck.
No, it's stuck like this because I didn't wanna, as I said already, this should be as much user friendly as possible. But trust me, 95% of data types are covered, 5% goes to string. And then later on, if you need to cast, you can use string functions. You can, like, you can take the parts out, you can cast to date or whatever you need. So you can work your way around if there's some complex string that I cannot cover.
Is it fair to say that the main impetus for this is because Rust really doesn't have a good data frame package?
Rust has good data frame packages. As I said, Polaris, very good data frame package, but user unfriendly, in my opinion. And the reason why they switch 100% to Python API is because even Rust users are having hard time to use it. So that was the question. Is there any? I think I.
Well, because of course, Pandas has one. This is not the Pandas API, and that's the more traditional, like Python-based. Or if you're using NumPy, then they have data frames there.
Yeah.
And they're more of a Pythonic kind of, square bracket, row column, whatever kind of thing where you would. And
yes, indexing and everything. Here you don't have indexing and stuff like this.
Kind of like ours data frames too, where you say row and column, and then there's a group by and stuff.
Yes.
Okay. I love this. So in the dashboard though, that's implemented as is that a JavaScript?
JavaScript, yeah.
Does that, like, if you create a report, is the report still active like this? Or
yes, it's interactive. It's HTML. When you run HTML, you close it, you open it, you refresh it, whatever you do, it's always active like this.
Is there a way to get just the dashboard part separate from the rest of the stuff? I mean, is it, because that seemed like
I just removed the PNG because I thought it's not necessary. But if you think, for example, it would be
no, what I mean is
let's
say because it seems like a separate layer, if you will, of your solution, where it's not specific to the data frame syntaxing or anything else, and would be very useful with just about any other data frame, for example, or anything else. Did you like come up with the dashboard as a custom implementation, or did you use some prepackaged
tools? So I use all our prepackaged use and all our community versions. So you're not ever gonna spend a dime on this. Also, one thing that is very important: this is open source from the first day, and it's free to use. And everything I'm implementing, I'm checking the licensing, and I'm checking is gonna be costly in the future. So all the packages from JavaScript for Excel is Ajax. The library for the Exceling and CSVs. For the AG-Grid is AG-Grid community license or community library. So it's free to use. So this is what I'm using. So AG-Grid for the tables, Ajax for the exporting, and the Plotly community version, not the paid one that goes in the dash, is used for the plotting. So everything is
Plotly dash. Is mostly Plotly dash is what you're using for this?
Not dash, just Plotly.
No,
Plotly and dash are separate thing. I'm not using dash because for dash is using they have if I remember correctly, they have a think of functions that you need to call the function on the action to recrunch the data every time. I think
no
for
worries,
dash.
No worries.
This is you need to have a constant connection with your data and with your queries. Once you create HTML, you are totally detached from your queries and from your implementation and from your execution. So this is the reason why I can implement dash, community version dash, but then I need to also figure out how to have constant connection with your data. So
and have sliders and things like that, interactive controls.
Yes. So currently I can do some gymnastics to create some functions to be able to filter the data that's in the HTML report. I can probably do this. Like here, you can filter. If you can see for the tables, you can filter the data. You can do stuff like this.
Yeah.
So yeah, you can do this for the tables, but it's not connected with the charts. It will be perfect if you can slider this, filter that, and everything is interactive. In this case, currently it's not, but yeah, it's the most recent. I just started doing this like maybe 10 days ago, 15 days ago. I don't know. So yeah, we'll work on more.
Okay.
We'll work
Thanks.
more on this.
Thanks a lot for answering my questions.
No problem. Okay, so pipeline scheduling. For me, this is very important. Okay, this is obviously in-memory data frame. This is obviously run in memory, but of course you can create a Rust image in a Docker, and you can create this more like, let's say, automatic. But again, if you have a computer in your company that is not doing much, or you can run this process through on your server through, let's say, shell script or something, you can also automate this like this. But for example, if you just open VS Code or any code ID that you're using, you can create your functions, your queries, whatever you want to do. You wrap it in a pipeline scheduler, and then you can set the then you can set the frequency of job repeating. So it comes from 1 minute to 30 days. I tried to implement, but it was failing so far. I tried to implement the exact time when you want to run the job, but it's based on UTC time. So now I wanted to cover all the time zones and everything, and it takes a lot of more things to cover and to think about, and to have internal evaluation of your daytime, your system daytime, then to check which time zone you are, then to a lot of stuff needs to be covered for this to work. So I just keep it currently like this. So for example, you run it right now, and it's gonna tell you, okay, process is finished, give you result, and then you're gonna tell next job run is that time, that minute, that second, based on the time that you have on your local machine, without knowing what is your time zone. Okay, so currently it's implemented like this. So you create pipeline scheduler new, you create how frequent you want job to be run in minutes, hours, or days, as you can see here on the right hand side. And then okay, this is a little bit more Rust specific, but just remember double pipe. Just remember this. If you're coming from Python, just double pipe, async, and then you wrap it in the curly brackets. Okay, just try to remember this like this. Don't think too much about this. I couldn't run the process multiple times without this. But anyways, just you go pipeline scheduler new, frequency, double pipe, async, and the curly brackets. And everything else is as you already saw. Here example is we are taking the data from Azure Blob Storage. We do some crunching, and we are saving data to Parquet. This is locally saving. You can also do saving back to Azure, for example. So you run this every day, once a day, or every 4 hours or every 6 hours, and it's gonna repeat its job. And this is implemented with Tokyo cron scheduler. So yeah, it's very, very interesting implementation, how they calculate minutes, hours, and everything. Okay, development. So we come to the end. I hope I didn't bore you too much. So currently what I'm working on, so as I said before, inline parameters for filtering and having. Problem here is security is problem here. Security is problem here, and I tried to implement something, but my audit was failing. There is different templating crates that you can use here, or you can use formatting, but it's kind of dangerous for for the for the injection, SQL injection. But maybe this is unreasonable to think, because if you're gonna use it locally, who can do anything to you, right? You use it, you execute it, you close it. But anyways, I couldn't because I have these GitHub actions that I'm running every time I'm uploading new version. It's failing, so I need to think very thoroughly about this because of security reasons, as well as how you're gonna be able to use it without, again, knowing too much Rust. That's very important. So try to make it simple and safe. It's kind of a challenge. So S3 connector, working on it. Date functions, I said already, working, still didn't cover all date functions from Data Fusion. And reading Parquet from Azure Blob, and writing, I didn't say this here, but as I mentioned before, writing JSON and CSV to Azure Blob. So these are 5 implementations that I'm currently working on. Of course, if anybody has any suggestion, please write to me. Tell me, okay, Bora, I need this for my job. Can you implement this? Give me a couple of days. We'll see what I can do, if I can implement something, because I'm using this for my job. I have very skeptical principle that use C# and .NET for many years. So it was very hard for me to convince him, okay, Rust is good. Let's use Rust. Rust is, you can do job, with less cost. We can do this locally. We can do da. But they're still skeptical, many people. But if you're gonna use this for your work, just tell me what you need. If you need to convince your boss, we can talk. We can schedule the chat. I can explain everything how it works. I can show implementations. Whatever you need, I'm here for you. I'm spending a lot of my free time on this without expecting anything in return, because first and foremost, I'm using this library for my work, and I'm doing this firstly for myself, okay, and then for everybody else. So please don't feel free to contact me to ask for any feature or anything that you need. I'm here to oblige. Is that the word? Okay, so thank you. If you are one of these 10,000 people that are using Elusion, thank you for using Elusion. Here is the crates. You can check the crates, GitHub, and my YouTube channel, where I'm posting from time to time. I'm not so active on YouTube channel. But yeah, so contact me, let's chat. I'm always open for chat and for implementations and for improvements. And of course, I do things wrong, and then I fix it. Okay, so I'm not, of course, perfect. Nobody's perfect, and this library is not perfect, but what it does currently, I think it does well. So yeah, that's it. And thank you for your patience. That would be it.
Well, thank you very much, Bora. It was a long but an excellent presentation.
Sorry, I told you before. I thought, 9 o'clock. Oh my God.
Thank you, Bora. Thank you.
Thank you.
Everybody must go. It was it was very interesting. Thank you so much.
My
Thank
pleasure,
you for and greetings from UK. Bye bye.
Bye bye. Bye bye.
Okay, so thank you
Bora,
for everyone, and thank you for the questions. Sorry?
Did you do any benchmarking? I mean, how is this an attractive thing for speed? Because I know
I did a lot of benchmarking. Still fastest Parquet reader and writer in the world for a single node execution, because I didn't implement this. This has come from Data Fusion. We have fastest reader and writer in the world. So if you need fast reading and writing with Parquet, okay, I was, as I said before, I was messing with appending. So it's not so easy, but still performance is
hard for appending.
Yeah, so appending is a little bit different, but writing and reading is the fastest in the world. For JSON reading, it's very, very fast, even for the flattening. I didn't want my selling point to be I'm faster than pandas, like some other libraries. I don't think that's the most important thing. I think the most important thing is accuracy and stability and safety, okay, and simplicity of using. Okay, so I'm not on a running track trying to beat anybody by speed. I want to create something that is safe, stable, and good to use. So yeah, I did benchmarking. There is some benchmark. I can post results from benchmarking, but yeah, as I said, most important thing.
I think it's not that hard to beat pandas. So in that
Yes,
case,
that's what I want to say. Some people brag they are faster than pandas.
Yeah,
but I never want to do this. Pandas is my love. I love pandas. I use pandas, like I was using pandas a lot before. So I would never trash and bash pandas on speed. Pandas is great. Go use pandas. Go use pandas.
Did you entertain the idea of using the pandas syntax?
As I said, the reason I was overwriting these 2 times, it's because the problem is with the data fusion different APIs. I tried to create very similarly in the beginning. If I go back to first couple of versions, it was very similar, like column dot function, or aggregations with dots like sum, mean, average. But as I said, I hit the wall for expansion with more complex things. Then I lean back on the SQL reference. It is what it is. It's life. You need to make your peace with the limitations and work on what you can work. Otherwise, I will need to implement like polars, everything from the scratch, all my functions, and then it would take a couple of years for this. But
yeah, the other thing that's come up with, because I've been working on a similar data frame package called Daffodil, and I invite you to take a look within Python. But one thing that's come up lately are embeddings. So they want to put in, say, like a NumPy array in one cell.
in
And
one cell, okay.
Yeah, so you want to have 384 bits. Sorry, 384 32-bit floating point numbers.
Okay.
And that's what fits into a CUDA, like a GPU at one time.
Okay.
So the record is these individual embeddings. And I didn't think this is the word that they use. So, and then they really don't want to index into these. So you want to put that into one cell. So what do you think the outlook is? Whoops. For putting in somehow, like, this is what Daffodil is good at because it uses Python data types, so you can nest whatever you want into a cell.
But tell me, you have a front end in what?
Daffodil is a Python package.
So no, okay, but you're saying cell. I'm imagining like a spreadsheet of some sort, and you are.
Yeah. So in your case, if there's a column and a row in a database, so you have a record and you have a column name, and that item normally is a number in there. Like in data frames, they think of it as one number.
Yes.
But what they want to do is put 384 32-bit floats, okay, in one cell. So they don't really want to split out and have 32-bit 384 columns because they never reference the columns.
Yes,
and so
but that is a tricky with a floating point in a single cell.
Now in Postgres, they have a thing called PG vector.
Okay.
Which provides not only that, but functionality in terms of doing nearest neighbor searches. So you can say, I want to look in n space. So the 384 is like a 384 dimensions, and you have a float, being where you are, and then each one of these maybe many hundreds of thousands of items are different, I guess, settings within a neural network or something, right? And so you want to find the nearest neighbor. And there's usually in PG vector and Postgres, they have 3 different ways of doing the searching. So that's one thing I was coming across lately of I'll just let you know in case other people may be interested in that within your package, that they may be wanting to have these embeddings. Okay.
I will need to see. I'll need to do some research on this.
Check out Postgres in terms of their terms of their PG vector, which I think is a third-party package. But yeah, you've done a lot, and I think that maybe my recommendation would be maybe to skinny down some of the things that you have in your package, so that you don't have so much to maintain. And allow people to implement things such as the API. I would probably recommend not having that in the package, because it isn't really, well, maybe you can come up with some sort of a very you know, simplified version of that or something. I don't
Yeah,
know.
I was thinking to split. I was thinking to create a couple of versions, like 3.0, 4.0, I don't know, something like this, and to strip,
Mm.
to just leave data frame in one version, and maybe like, you know, in 4.0 to add dashboarding, in this one to add API, something like this, because yeah, it's heavy. Just to test single
I
thing
think it's
takes
kind of heavy. Yeah.
takes
And
5-6 minutes to compile, and I'm waiting.
well, the thing
You
is,
know,
is that
it's
also you're
getting
doing a lot
wild.
of redoing of the SQL syntax. And I would wonder, because I was thinking about a similar extension to Daffodil. And my first way of wondering it would be better is to just allow people to put the SQL in a string, right? And let them just run that. Now, once you do that, when what you're doing, you may as well just use it directly. But
Yeah.
for the Daffodil has a syntax that's similar to what Python normally uses with rows and columns indices, right? And then
Yes.
those can be strings or integers, or they can be lists of strings or lists of ranges or whatever you want. And then you can select from your data frame. And what I was looking at doing was, because everything is fine with Daffodil in memory. Yeah, I don't need to do any of the SQL commands. And also the one thing that it lets you do very well is to use Python, you know, custom functionality to create new things. And that may be something that would be hard to do. I know they have, I was looking in the documentation for Data Fusion where they have, where you can create a function, a custom function, right? And it's for the whole, it looks like they take a whole data frame. You take one data frame, maybe two, and create a result.
Yes.
Yes. That's okay.
That's not the approach I think that you want, I think.
No, I'm just saying that
Yeah.
that with you, if you stay in Python data types, so there's a data type conversion issue when you go from Python into pandas. It takes forever. I mean, to go from, you know, when you think of it, basically, unless you're doing 32 columnar functions like summing, that, you know, deviations, max, min, all of that stuff on columns that you want to do, which pandas is really fast doing those. But you have to do 32 of them to make it worth changing from Python data types into pandas. It takes that long. So what I was doing initially, I was using pandas all the time. I was just using data frames like nothing's flat. And I found that I was going in and out of them. And this was a big hog of my time because I was time sensitive. And so then I was saying, well, I'm just going to stay within Python data types, and it runs much better and easier in many ways, and sometimes smaller too. But it is something that people are used to the syntax of pandas, you know, and if you go to them and you say, I want you to use a new data frame methodology, and if you say it uses the same syntax as pandas, but it's, you know, 10 times faster or whatever,
big problem.
then they go, oh, that's great. That's great. You can just pop it right in. And so anyway, so thank you so much. I would like to continue the conversation. I'm doing a presentation, I think is it March? March
on Daffodil,
5th on Daffodil. Come and take a look at that. I really like your dashboarding. I would like to somehow adopt that and maybe port that over to Daffodil. Because that's pretty cool and would be really helpful to and maybe it is easy if you're using a lot of stuff I just don't know what those packages are that you were using. But I'll take a look at your code and see.
It's very easy. I am like a C++ programmer. I'm like a header file. It's very easy to go through my code. I'm not a modular guy. So you find one file and you find everything you need.
Perfect. Hey, Bora, thank you so much for your time. Appreciate it.
Thank you for all the questions and for engagement. It was very helpful because some things I would forget if you didn't ask.
I like it better when people ask questions myself because
Yes.
it's like, oh, gee, I'm actually bouncing off something other than just names on a wall. Okay, thanks a lot.
Thank you, Ray. Thank you.
Again, thank you for both of you. It was even more interesting.
It was 3 hours long, but thank you.
Yeah, okay, it's fine. So thank you very much, everyone, and goodbye.
Okay, ciao, ciao.